Today, I, Payal Rora, will be presenting on the topic max flow min cut theorem before you. So let's just first start with the basic terms. The first term, that is cut. An ST cut in a flow network G, that is equal to VE, is a partition of vertices V into two disjoint subsets S and T, such that small s belongs to big S and small t belongs to big T. Take for example S equals to S and 1 and T equals to 2 and T. The capacity of a cut ST is cap ST equals to summation U belongs to S into summation V belongs to T, C of U and V. Now let's see the next term, that is augmenting paths. An augmenting path is a path from S to T in the residual network. The residual capacity of any augmented path P is rho P, that is equal to min of R of I and J, that is to I and J that belongs to P. Now let's see augmentation along P. First of all, add rho P in each arc along P in flow network. Then modify residual capacities in residual network. Therefore, R of UV equals to R of UV minus rho P, and R of V and U equals to R of VU plus rho P for U. Therefore, V belongs to P. Now let's see the main max flow min cut theorem. The following are equivalent for the theorem. First point, a flow X is maximum. The second point, there is no augmenting path in G of X. And the last point, that there is an ST cut set whose capacity is the flow value of X. Let's come to the corollary now. The corollary of this theorem is that the maximum flow value is the minimum value of a cut. Now, let's prove this theorem. 1 is equal to 2 also implies that not 2 is equal to not 1. Suppose that there is an augmenting path in G of X, then X is not maximum. Suppose that 3 equals to 1. Now let V equals to f of X of S and T be the flow from S to T by assumption V equals to cap of S and T. By weak duality, the maximum flow is at most cap of S and T. Thus, the flow is maximum. Now, 2 equals to 3. Suppose there is no augmenting path in G of X. So, let's claim that let S be the set of nodes reachable from S in G of X. Let T equals to N by S. Then, there is no arc in G of X from S to T. Similarly, here I belongs to S and J belongs to T. That implies f of I of J is equal to C of I and J. I belongs to T and J belongs to S implies that f of I and J is equal to 0. Therefore, there is no arc from S to T in G of X. Therefore, it follows that f of X of S and T is equal to summation of I belongs to S and summation of J belongs to T into C of I and J minus summation of I belongs to S into summation of J belongs to T 0 is equal to cap of ST. This was all about the max min flow cut theorem. Thank you.